Good morning. Welcome to lesson 15. So today we're going to cover inverse variation, the new subtopic. Okay, so we have done our direct variation. Okay, and I'm going to discuss the homework with you in page 104, question number 5. Please refer to that page. Okay, I hope you guys have done this question number 5 already. Okay, so question number 5, it is given that W is directly proportional to T. Okay, let's recap back what is direct proportion here. So we can write this in this form. So W is direct proportional to T. So W is equals to K times T, right? Okay, so when T equals to 4, W equals to 20. Okay, so from there we need to find our constant K, right? Our constant K here is substitute in your W 20 here and your T, which is your 4, and then you will find that your K is 5. So W equals to 5T. Okay, so from here we can find our value of W when T equals to 6. So we just sub in the 6 into the equation here. 5 times 6 is 30, and then part B is 45 equals to 5T because your W is 45. Okay, this comes from the equation W equals to 5 times T, and then there we go, T is equals to 9. So please tick your answer. Okay, so in this question, if you do a cross multiply method, okay, it's fine. Yeah, you can do that, but please don't do like this, right? Please don't do 4 is equals to 20, because 4 is not equals to 20, because your T equals to 4, your W equals to 20, so you cannot write in equal form. So if you were to write cross multiply method, then it will be 4, which is your T, and your W is 20. So 4 is to 20. You can do that way, but I would suggest you to do in this form, okay, in a K form. Okay, in the constant, you need to find the constant. You need to do in this way because question, sometimes they will ask you to find the equation connecting from W to T, or finding equation connecting W and T. So in that case, you need to find the constant K. Okay, so you need to find the equation of it, because sometimes they will say, okay, find W in terms of T. So in that way, if you do cross multiply method, okay, you won't find the equation. You don't know what is the constant, right? So please do it this way. Okay, if you already do this cross multiply method way, okay, which I'm not going to discuss with you how to do that way because you learned this in year 8 already. Okay, but I want you to write again one more time in this form. Okay, you need to find K. Okay, you need to find the equation, this part. I want to see this one in your notebook. Okay, W equals to 5T. Okay, and cross multiply method, it won't work for question like question number 6, right? Because this involves R square. Okay, so if you cross multiply using R equals to 5 and A equals to 75, you won't get the answer. Okay, just to let you know why I teach this in this way, okay, this method, okay, because we have to find K, okay, constant. Okay, so question number 5 we have done. Okay, we finished our question number 5. So now let's proceed to 4.3, which is inverse variation. Okay, please write down the date, the title, okay, and please copy the question as well. Okay, so try it 6 is in page 110. Okay, before we go to try it 6, okay, I'll let you know what I'm going to do today. So we are going to do try it 6. Okay, try it 6, page 110, and also exercise 4.3, question number 1, 2, and 3. Okay, and question number 7 as your homework. Okay, so just like direct variation, we know inverse variation already. You learned this in year 8, okay, but I'm going to elaborate a little bit more explanation or illustration on our daily life, what is basically inverse variation means, right? Okay, so like direct variation, I've used the example of using the Milo. Remember the number of Milo pack and the price of the Milo. So you know that direct variation, okay, both x and y will increase. When x increasing, y will be increasing as well, right? Okay, that is for direct variation. And we have the constant k when y is equals to k times x, okay? So how about inverse variation? Okay, inverse variation. Okay, I give you an example of inverse variation. Okay, so let's say we have a speed of a vehicle, let's say a bus, a speed of a bus, okay, and also the time. Let's say you are traveling from Chonghua to Gadong using a bus, okay. You are traveling from Chonghua to Gadong, let's say, using a bus. Okay, so of course your bus, you will have a speed, and of course you will have time consumed from traveling from Chonghua to Gadong, right? Okay, so let's say it will take you 20 minutes, okay, time in minutes, okay, time is in minutes. Let's say it will take you 20 minutes, okay, for you to go from Chonghua to Gadong with a speed of the bus which is 30 kilometer per hour. Okay, your speed is in kilometer per hour. Okay, if you're aware of your parents' vehicle, okay, you can look at the speed. Okay, the normal speed of course is around 60 to 80. Okay, not more than that definitely. Okay, so your speed, let's say, is 30 kilometer per hour. That is quite slow actually. 20 minutes from you to travel from Chonghua to Gadong again. Okay, so if let's say the speed up, okay, you speed up from the bus, speed up to 60 kilometer per hour, okay, 60 kilometer per hour. So will the time increase? Think about it. Okay, if let's say you are going faster now from by the bus, you're using the bus going faster now, the speed is increasing. Okay, so you will reach Gadong less than 20 minutes or more than 20 minutes. Okay, it will make sense to you that the time will be less than that. Okay, so if the speed double up, so your time definitely will be decreasing by half, right? So it makes sense that if you are traveling to Gadong with a speed of 60 km per hour, so your time will become less than 20 minutes, which is 10 minutes. Am I right? Okay, let's say the speed of the bus increase to 120 km per hour. Okay, and you're traveling from Chonghua to Gadong also. So if the speed from 30 become 120, okay, so the time will become less, 5 minutes. So you will reach in 5 minutes if the speed of the bus is 120. Okay, this is only illustration and example. Okay, the bus cannot drive that fast. Okay, 120 is too fast. Okay, you have traffic everywhere. Okay, we just assume that, let's say, it's a straight line to Gadong with a speed of 120 km per hour, you definitely will reach there in 5 minutes time. Okay, right, so you can see that it's different with direct variation. Direct variation increasing both x and y, right? Okay, so let's say your speed here is your x and your time here is y. Okay, so now we can know that our speed increasing, when our speed increasing, our time here decrease, right? So this is what we call inverse variation. Okay, so this is what we call inverse variation. So from here also we can actually find our constant. Okay, unlike the constant is in direct variation, we use divide. Okay, in direct variation, okay, direct variation, we use y divided by x, which is your constant k, right? And in inverse variation, we times. Okay, so we times x and y to show that they are inverse variation. Okay, to show that they are inverse variation, we times x and y. So 30, when we times with 20, we will get 600. Okay, this part, correct? Okay, and then the second one, 60, when we times with 10, we will get 600 also. Okay, and then 120, when we times with 5, we will get 600. So what we can say here is our constant now is x times y equals to your k, which is your constant, and your constant here is 600. Okay, so when we times and we have a constant, we can say that x is inversely proportional to y, or we can say x varies inversely to y. Okay, it's the same thing. Or we can say that the speed of a vehicle, of the bus, okay, the speed of the bus is inversely proportional to the time it takes to travel at a fixed distance, of course. Fixed distance as in, as I mentioned just now, is from Chonghua to Gadong. It's not Chonghua to anywhere else. Okay, it's a fixed distance. And the speed of a bus is inversely proportional to the time it takes. Okay, right. So this is one of the example. Okay, I give you another example of inverse variation to make you more understand, just in case if you don't not really understand about the speed and time, right? Okay, so let's say we are cleaning the classroom. Okay, so we have a number of minutes, okay, the time, the number of minutes to clean up the classroom, and we have a number of student who clean the classroom. Okay, student or students. Okay, so let's say we have one student to clean the classroom, the whole classroom, including wipe the whiteboard, arrange the table and everything, and it takes 60 minutes to clean up everything. Okay, so what if we have two students, we have another one more student to help out? Okay, so the number of minutes, the time, is it increasing or decreasing? Which one makes sense to you? If you have more students to help out to clean up the classroom, you have more people, of course the number of minutes, the time to consume to clean up the classroom will decrease. Okay, so it will become 30 minutes. Okay, 30 minutes. So the more students to help out, the less time to clean up the classroom, right? Okay, so if we have another one more helper, 3 students, it will become 20 minutes. Okay, the time decreasing again. Okay, so you have 4 students, so we have 15 minutes to clean up the classroom. So the more students to help out, the less time to clean up the classroom. Okay, so from here, we can find our constant basically. So let's say the number of minutes is your x and your number of students is y. So to show that this is actually really an inverse variation, we need to find the constant. Okay, even though the number of minutes here is decreasing, the number of students is increasing. Okay, so for inverse variation, okay, one increase, one decrease. Okay, for direct variation, it's either both of the x and the y are increasing. Okay, so to show that it's really an inverse variation, we need to find a constant. Okay, so the constant here is 60. You times with the 1 is 60. 30 times 2 you get 60, 20 times 3 you get 60 also, and 15 times 4 is also 60. So the constant here is 60. So we can say that x, when we times with the y, is equals to 60, and we can say that the number of minutes to clean up the classroom is inversely proportional to the number of the students. Okay, right, or the number of minutes to clean the classroom is varies inversely to the number of students. Okay, so let's go to try it. The following table shows the corresponding volume of air inside a syringe when the air pressure is P units. Okay, so we are given a table here, okay, with pressure in P units and volume in V centimeter cube. Show that P and V are in inverse variation. Okay, we are showing that they are in inverse variation by finding the constant. Okay, so we need to find the constant. If they are the same, it means that they are inverse proportion. Okay, so we times P, we times with V. Okay, so the first part here, 1 and 120. Okay, so we times 1 times 120. Okay, we get 120. Second part, 2 times 60, we also get 120. Here, 3 times 40, also we get 120. And 4 times 30, we get 120. 5 we times with 24, we get 120 also. And the last one, 6 times 20, we got 120. So all here is 120. So here we have shown that it's a inverse variation because we have found our constant, and the constant is actually 120. Okay, so your K here is 120. So here we can say that P is inversely proportional to V. Okay, this is how we show that it's a inverse variation or inverse proportion by finding the constant. Okay, so now part B, draw the graph of V against P. So your V is y-axis, your P is x-axis. Okay, so this is your y-axis and pressure P unit is your x-axis. Okay, so prepare a graph. Okay, I prepare my graph here. Okay, so let's label. Okay, so part B here. Okay, V against P again. Okay, so we label V and P. Okay, V is on y-axis and P is on x-axis. Okay, so look back at the table. Okay, so you label x-axis as 1, 2, 3, 4, 5, 6 or 1 unit, 1 centimeter represented by 2 centimeter represented by 1 unit. Okay, 1, 2 cm, 2, 3, 4, 5, 6. Okay, as for y-axis, the volume, so the highest is 120, so let it be 1 centimeter represented by 10 units. So we have 10, 20, 30, 40, 50, 60, 70, 80, 90, and 120. Okay, so the scale here according to this, you can follow this one, and then let's plot the graph. Okay, so 1 is to 120. You can pause the video and plot it by yourself first before you continue with the lesson. Okay, you can try first. 340, 430, 524, and 620. Okay, you take your time and draw the graph, right? Okay, after you plot, it's very obvious that it's not a straight line. Okay, it's not a straight line, it's a curve. Okay, it's a curve, and we call this as hyperbola. Okay, it's a hyperbola graph. Okay, hyperbola. Okay, from the textbook I can show you. Okay, it's called a hyperbola. Okay, I explain to you this one first. I want you to write this down into your notebook also. Okay, this one. When two quantities x and y vary in such a way that x, y is a constant, okay, just like I said just now, right? Okay, you write it in a corner or anywhere, any space in your notebook, right? So in such a way that x, y is a constant. Okay, so it means that x times y equals to k. Okay, when two quantities x and y, x times y is a constant, they are said to be in inverse variation, so it's called inverse variation, or y is said to be inversely proportional to x. Okay, so this note over here basically is the same meaning as what I said just now in part A. Okay, we show that it's an inverse variation by times xy or PV. Okay, here we times PV, and if we get a constant, it can be said that it's a P is inversely proportional to V. Okay, it's the same meaning as this yellow box here. Okay, so you look at this figure 1. Okay, if we were to plot y against x graph, okay, for an inverse variation, the graph will look like this. Okay, it's a hyperbola graph. Okay, it's a hyperbola. Look at this hyperbola, right? So for direct variation, it's a straight line if y against x. Okay, what happened if y against 1 over x for inverse variation? Okay, this is inverse variation, both also inverse variation. For y against x, it will look like hyperbola, and y against 1 over x, if we plot y over 1 over x, okay, y against 1 over x, it will become a straight line. Okay, it will become a straight line. Okay, it will become a straight line. So let's see if we get a straight line if we draw part C. Okay, but part B we have done. Okay, V against P, we'll get a hyperbola. Okay, for part C, draw the graph of V against 1 over P. Now, our y-axis is V, our x-axis is 1 over P. Okay, but the table here, we are not given 1 over P, we are only given V and P. So what we are going to do is we have to restructure the table again. We have to write down or build a table, another table, okay, connecting P and 1, connecting V and 1 over P. Okay, so this is the table. Basically it's the same as this. I just cut and paste here. Okay, and we have to find 1 over P. Okay, leave a space for yourself to find 1 over P. Okay, 1 over P. So you need to add on 1 over P into the table. Okay, you draw it nicely. Okay, you have to rebuild again the table. So find 1 over P for according to the P here. So 1 over P is already here. So 1 over P is basically 1 over 1. Okay, 1 over 1, which gives you 1. Okay, and then the other one is 2. So 1 over P will become 1 over 2, and it gives you 0.5. Okay, and as for here 3, so it's 1 over P, right? So 1 over 3, which gives you a 0.33. Okay, make it into 2 decimal places. Okay, because when we draw our graph, when you plot the graph, for fraction it's hard to see, so it's better for you to change it to decimal. Okay, and 1 over 4 is equals to 0.25, 1 over 5 is 0.2, and then 1 over 6 is equals to 0.17. Okay, so you draw the table nicely. Okay, you do it nicely, huh? Okay, then you can draw your graph. Okay, you can draw your graph now. So V against 1 over P. Okay, now you plot first. V against 1 over P. Now you use the same V, but the P, 1 over P, you use the one that you have calculated just now. Okay, that you have already changed to 1 over P. Alright, so the scale here, since the one, okay, we label one for the x-axis first. Okay, x-axis, the largest is 1. Okay, don't look at the P here. Okay, you look at 1 over P, the one on the top here, 1 over P. Okay, so it's the largest is 1, so we can say that we plot 0.1 for each centimeter. Okay, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and 1. Okay, or 1.0. Okay, so 1 cm represented by 0.1 unit. Okay, so for V, the same as part B just now. So 10, 20, 30, 40, 50, 60, 70, 80, 90. Okay, and then you plot the graph. Okay, so 1 to 120. Okay, you can pause the video and plot the graph yourself. 1 to 120. Okay, and then look at the second one. 0.5, 60, not 2, 0.5, 60. You are plotting according to the new table. Okay, according to the new table. And then 0.33 to 40. 0.33 to 40 is here. Okay, 0.3. Because 0.32, 0.33 is in between 0.32 and 0.34. Okay, next is 0.25, 30. 0.25 is here and 30. Okay, and then 0.2, 24. And then 0.17, 20. Okay, now. Okay, so it's a straight line graph. It's a straight line graph passing through origin also. Okay. Okay, so this is your graph. It's a straight line passing through 0, but okay, I want you to circle all here. Okay, you circle this all here. Okay, it means that it doesn't include the 0. Okay, the graph passing through origin. Okay, the graph it touch at 0 here, but it means that it does not include the 0. Okay, why do I say that it doesn't include 0? Okay, because 1 over p, okay, this is your 1 over p, right? Your x-axis is 1 over p. So if it's 0, it means that it's 1 over 0. Okay, it means that your p is 0. So if your p is 0, what happens if 1 over 0? So 1 over 0, it will be math error. Okay, it cannot be 1 over 0 is not 0, 1 over 0, if you press calculator, is math error, okay? It doesn't exist. Okay, it's undefined. Okay, so you circle that part, which means it doesn't include the 0. Okay, look at the textbook here again. Look at it. This. If we draw y against 1 over x, okay? If we draw y against 1 over x, okay? For variation, for inverse variation, okay? It doesn't include here, it doesn't include the 0. Okay, so this part, okay, you can copy this down. The graph of y against 1 over x is part of a straight line which passes through the origin. Yes, it's passing through the origin, but okay, since 1 over x is never 0, it's never 0, so the origin is not on the graph. Okay, it's not including, okay, it's not including the 0 there. Okay, now this one, remark, or yeah, this one also you copy, right? In the graph of y equals to 1 over x, the small circle at the origin indicates that the point 0, 0 is not included. Okay, you can write in a way you can refer back and you understand. Okay, no need to actually copy every single words here, right? Okay, just indicate, just write there to refer, so that you can refer that by yourself. When you go back to that page, you will know that it doesn't include 0. Okay, but our graph, okay, we still draw touching at that part, but the circle, it means it doesn't include the 0. Okay, so this is part C. V against 1 over P. Okay, so now let's do part D. Find the equation connecting P and V. Okay, so since part A, we already found our constant. Okay, so P is inversely proportional to V, right? So we can write straight away that P times V is equals to 120. So this is the equation connecting P and V. Or what we normally write down is P is inversely proportional to V. This is what we normally write. P is equals to 120 divided by V over V. Okay, this is what we normally write. Okay, but both answers we accept because they are actually the same. See, the V, if you move to the other side, is divided by V. Okay, now part E. Find the volume of air when the air pressure is 8 units. So volume of air is V, pressure is P. So we are looking for V when P is equals to 8. So we just sub in since we already have the equation here. Okay, so we just need to sub in your P, which is 8. So 8V equals to 120. So your V is equals to 120 divided by 8. And you get a 15 centimeter cube because of the volume. Okay, so that's it for try it 6. Okay, now we proceed to exercise 4.3. Okay, question 1, 2, 3. Okay, so part 1, question 1. In each of the following tables of values, determine whether x and y are in inverse variation. So to determine whether it's a inverse variation, so what we do is we find the constant. Okay, we find the constant. So to find the constant in inverse variation, we times. Okay, x we times with the y. So x we times with the y, we get 1 times 12, and we get 12. And second part here, 2 when we times with 10, we get a 20. So since one is 12, another one is 20, can we say it's a inverse version? Definitely no. Okay, so 3 times 8, okay, 24. 4 times 6 is 24. Not the same. So if they're not the same constant, the k is not the same, so we can say that this is not inverse variation. Okay, B. Part B, same thing, x we times with the y. Okay, x we times with the y, and we get 2 times 12 here is 24. Okay, and then 4 times 6, we get 24. 6 times with the 4, we get 24 also. And here 8 times 3, we get also 24. So here we can say that the constant is 24. So the equation connecting x and y will be x, y equals to 24. Or y is inversely proportional to x. Y is inversely proportional to x with a constant of 24. Okay, so you write down the equation here. Oh, I forgot to write yes. Okay, yes, it's an inverse variation. Okay, so part C, part D. Okay, I leave it to you to do. Okay. Question number 2. So in each of the following graph, determine whether x and y are in inverse variation. Okay, so again, is if we say that it's an inverse variation, we have 2 types of graph. Okay, to show that it's inverse graph and is inverse variation. So if y x against x, it will be a hyperbola, and if y against 1 over x, it will be a straight line. Okay, this is for inverse variation. Okay, so part A, is this considered an inverse variation? It's no. Okay, it's not inverse variation. Why? Because for y against x, it will be a hyperbola graph, but this is not hyperbola, so it's not inverse. Okay, part B, this is y against 1 over x. Okay, So for y against 1 over x is a straight line passing through 0 but doesn't include 0, right? So you look at this, it's drawing a O there. I mean, it's circle a origin there. It means it doesn't include 0. So yes, this is inverse variation. Okay, number 3. In each of the following equation, determine whether x and y are in inverse variation. Okay, so for equation, inverse variation is y equals to k over x, okay, or x times y equals to k. Okay, either one of these is inverse variation. Okay, either one of these, either y equals to k over x or xy equals to k. Okay, let's look at A. So part A here, x times y equals to 20, so it's a variation, it's an inverse variation with the k of equals to 20. Okay, part B, x minus y, so it's obviously no, it's not inverse variation. And part C, y equals to 18 over x, so yes, it is an inverse variation with the k equals to 18. Okay, and part D, y equals to 1 over x, but with a plus 1. Okay, it's no, it's not inverse variation. Okay, so okay, question number 3 done. So question number 7, you do it by yourself. Okay, you do it yourself, question number 7. So your homework, by the way, this exercise 4.3 is in page 113. Okay, write it down, page 113. And question number 7 is in page 114. Okay, so your homework is page 113, exercise 4.3, question number 1 CD, and page 114, question number 7. Okay, please do your homework. Okay, so I hope you prepared the graph paper. Okay, if you don't have a graph paper and you cannot find or cannot buy, obviously you can buy it from Me or anywhere else. Okay, if you cannot buy, I have provided a graph paper for you already, and you just need to print it out, the graph paper. Okay, it's in the Teams. Okay, you can find it under file. Okay, under file, under the file tab in my in the maths post, under the file tab. Okay, or you can text me. You can text me anytime where you can find the graph paper. Okay, you can print it out, but I would encourage you to go and buy it. Okay, I've asked you to prepare it earlier already, so I hope you prepare that. Okay, so that's all from me, and I will randomly pick some of you to send me pictures of your exercise, okay, and send to me through Teams. Okay, so that's all from me. Thank you guys, bye.